Good evening. My name is Ritesh Misra. There are few questions mailed by the students. The questions based on electrophilic aromatic substitution reactions, and the students asking about, sir, where the electrophile will attach on this group. There are total 6 questions on the basis of electrophilic aromatic substitution reactions. So let's solve the questions and understand where the electrophile will attach. Okay, so let's start. Let's see here. The first question, let me tell you, they ask about, sir, tell me where that, at which positions the electrophile will attach on the following questions. Okay, strengths, let's understand at which positions electrophile attach. The first question is their strengths here. They ask about, this is the first questions. They ask about, what is the questions here? Okay, so here is that benzene and CH3 is there and the Cl is there, correct. So Br2 and Fe is attached there in the presence of Fe. Obviously, it is electrophilic substitution reactions, but a student asking about, said, at which positions will attach. Student, before giving the reply, giving the answer of these questions, three things I want to tell you. The first thing is that there is a minor conditions for the electrophilic substitution reaction in di-substituted benzene. First condition is that if activating and deactivating group both are present. If activating and deactivating group both are present in the benzene ring, then any electrophile will attach, then any electrophile will be determined by activating group. Okay, so suppose you have this compound, one is that CS3 and second is that NO2, right? So any electrophile, how to attach? Student, this electrophile, attachment of this electrophile will be determined by which is the electron donating group. So CS3 and NO2, this is the NO2. So NO2 is the electron, a strong deactivating group, and CS3 is a strong activating group. So here in the benzene ring, the two group attach. One is activating, second is deactivating group. So just I spoke about that. When the activating and deactivating group both present in the system in the benzene ring, then any electrophile will attach on the basis of the activating group. So CS3 is activating group. So any electrophile will attach on the basis of this CS3 group. Here is ortho, meta, para, or from the left side, ortho, meta, para. So your para position is occupied. So you have only one position, ortho position, either this position and here, this position. So either electrophile will attach here or will attach here. Understood? This is the first condition. Second condition is here, sir, if both group present, both group is a deactivating group. Suppose here is that one deactivating group is that CHO and second deactivating group is NO2, correct? So if both group present as a deactivator, both are deactivator group, correct? Then the position of electrophile strength will be determined by the strong deactivator group. See, CHO and NO2 is most deactivator group. So any NO2 is most deactivator group, it means the electron density only at meta positions. So electron density only at meta positions, it means that will attach ortho meta positions or ortho meta positions, correct? So electrophile attach either these positions or that positions, correct? Understood or not? Strengths, again I repeat it, CHO and NO2 both are a strong deactivator group. Then the rule is saying that if both deactivator group present in the benzene ring, then your electrophile, attachment of the electrophile depends on which is a stronger deactivator group. So see, NO2 is a stronger deactivator group, so electrophile will attach on the behalf of this NO2. So ortho, meta, para. So electrophile will attach on these positions, correct? Now your questions, you can ask the one question. Sir, suppose this position is occupied here, some group is attached. Then obviously then electrophile will attach on these positions. Done. Third condition strength here is, sir, if both group activating group is present. Suppose here is that one is CH3 and second is OH, correct? If both activating group is present, then what will happen where electrophile is going to be attached? Strength, when both group are activating group, then position of electrophile will be determined by a strong activator. Strength CH3 and OH, which is a very, very strong activator. Of course, OH is very strong activator group. Then your electrophile will attach on the basis of OH, means ortho, meta, para. Okay, so your para position occupied. Of course, you have only ortho position is remains. So electrophile will attach either here or at this place. Understood? So now we'll go to the questions. Now you will understand the questions. Here is the okay. Here is that B chlorine and CS3 strength. Chlorine and CS3. Now here is a twist in the questions. Because here is rule is going to be violated. Strength CS3 is what? CS3 is activating group. This is the activating group, correct? This is the activating group. And Cl is deactivating group. This is the deactivating group. According to rule, any electrophile should attach according to activating group. It means the bromine should attach at the para positions, at this position with respect to CS3, correct? But that's not a true strength. That's not a true. Why? Because CS3 is activating group. Yes, correct. And chlorine is deactivating group. And the CH3 and the Cl strengths both will be the orthopara directing group. Both are orthopara directing group, despite being any electrophile will attach with respect to the chlorine, because chlorine shows the resonance effect. There is a lone pair, so that will show the resonance effect. And electron density will be increases in the benzene ring with respect to chlorine, because chlorine shows the resonance effect. Okay, so as you remember strength, when the chlorine attach in the benzene ring, the two effects operate. One is that resonance effect, the second is the inductive effect. Although in the 99% resonance is stronger than the inductive effect, but when the chlorine attached with the benzene ring, the inductive effect is stronger than the resonance effect. It is very, very interesting. So anyway, what I want to tell you that the chlorine is donating, that will is resonance is there, so that will supply the electron on the benzene ring, so that electron density at this ortho, meta, para. So electron density increases at these positions. Okay, so these positions your bromine will attach here. Where the weapon, bromine will attach here. Done. Okay, now next question is there here is your next question is there, what was the okay, second question you ask about this compound is here, and C double bond O, and here is this group is there, correct? So what will happen, Br2 or Fe is there. Student, see here, there is a lone pair. So what happen, again, C double bond O, this is the group. C double bond O strengths, what happen when the resonance will be happen, the positive charge will happen, correct? And the positive charge on the any substances attached with the benzene, it means that is electron withdrawing group. And C double bond O is the what electron withdrawing group, and this is the, here is the electron density is going to be increases on these positions. Okay, so since electron density is going to be increases at this position, so it will show the plus M effect. So that will donate the electron in the benzene ring. Okay, and although here is resonance is also the conjugate resonance is there, but despite being here will be a mesomeric effect. So ortho, meta, para. So para positions is the electron density will be increases. Now your question, sir, why in this side there is no mesomeric effect? Yes, because plus positive charge is there. So there is a resonance is here. So positive charge will come on this nuclear chain on the carbon. The nuclear side of the carbon means just benzene attached with the carbon. There is a positive charge is there. So it means directly deactivating group is there. So therefore, the electron density at this side, hence the ortho para positions, any electrophile will attach. So para position will attach because high density. So bromine will attach here. Correct? Student, your next questions was the you ask about one questions here is one C double bond O and NH, correct? And here is NH. So and there is a group here is. Students, see here. Now question is that bromine Br2 Fe. See here, students, there is lone pair. Here is the mesomeric effect. Here is also a student mesomeric effect, correct? But here is a lone pair. It will be the conjugation. The lone pair here will be the conjugations, but here lone pair is no conjugation. So it means the here is a mesomeric effect more than this chain, correct? So it means if here is a mesomeric effect is more, so ortho meta para, so these positions the bromine will attach here, correct or not? So ortho meta para, so at these positions bromine will attach here. I repeat, both the positions there is a mesomeric effect, but here is the mesomeric effect will be less than this side because here is the due to the conjugation, there will be the conjugation strength. Here is no conjugation, so directly lone pair will donate to this benzene ring. Hence, ortho meta para. So at this para position, Br will attach at these positions. Okay. Now your next question you ask about here is the group and C double bond O and H. Here is that O C double bond O, and here is okay. You ask about, sir, which positions that any electrophile will attach, that is the Br2 or Fe. Student, again I repeat, one thing I would like to tell you, students, O C double bond O and C double bond O. Student, this is the most this is the more plus M effect than this, correct? So you have to learn the order. Students, OR is the most, like OR is the more electrophilic aromatic substitution reaction favored, then the NH C double bond OR, and then OC double bond OR. Okay, so here is also mesomeric effect. Here is also mesomeric effect. Both will favor the mesomeric effect, but these positions that group will favor the more mesomeric effect than C double bond OO. So obviously here the less more mesomeric effect means that will supply more electron towards the benzene, that will supply more electron in the benzene ring. So we have to go with respect to C double bond O NH group. Okay, so since it has a more mesomeric effect, so ortho meta para, correct? As you know, the more mesomeric effect means more plus M effect means ortho para, correct na? So plus M effect means ortho para positions, correct na? So both the compound will show the mesomeric effect, but here mesomeric effect is more. It means it will supply more electrons to the benzene ring than this compound. So here is, so obviously both the lone pair will move into the conjugation. It also move in the conjugation, but their conjugation will be less than this side because here is a nitrogen, here is the oxygen. So nitrogen is a less electronegative than the oxygens. So the ortho meta para, so these positions, the any bromine will attach here. Okay. Okay, next question you ask about one. See here that C double bond O and H and C double bond O O, and here is this exactly, student, same thing you will apply here. So same thing will apply here, correct na? Here is the more mesomeric effect, here is less mesomeric effect. This position has more mesomeric, this position less mesomeric effect. So it means more mesomeric means more electron density towards the benzene. So ortho meta para. So these positions will be the bromine will be attached on these positions. Okay, correct na? Okay. Now your last question is that you ask about. You have sent these questions. So now you have here is student, these positions, two position is the resonance is there. So what happened? This is the delocalized lone pair. So what happened? The lone pair will come here. That resonance is there. So ultimately, here is the H. So double bond. Here is double bond. Here is the negative charge. So again, what happened? So that will move here, and ultimately here N H, and so negative charge is there. So any bromine will attach at these positions. Okay. So I hope, students, you understood. If you understood the concept clearly, please subscribe the channel, share with your friends so that they will understand perfectly. And if you are most happy to understand the after this understanding this concept, please like the video also.